Alright guys, welcome to 2.2, the distributive property. We're going to kind of get into that today. Well, what is the distributive property? Well, in algebraic form, what it basically means is that if you have some letter or some number A, and you have it next to a parentheses, and inside the parentheses you have B plus C, that is equivalent to saying A times B plus A times C. Now, how did I get that? Well, this part was gotten by taking this A and distributing it to the B, A with multiplication, so A times B. And then this part was gotten right there by taking the A and distributing him with multiplication to the C. Alright, so in this case we would just leave it because we can't go any further with it. However, it does help us with situations like 4 times 6 plus 3. Okay? Now, there are two ways of approaching this problem. We could say, oh, here, okay, this expression has a parentheses in it, so I need to obey order of operations. And you could certainly do that if you wanted to. Order of operations would mean I need to add the 6 and the 3 first, so that'd be like saying 4 times 9, which is 36. But if I wanted to use the distributive property, which sometimes you're going to have to, you're not going to be given the option of just using order of operations, that would be like saying, I have 4 times 6 plus 3. I'm going to distribute the 4 to the 6 with multiplication, so 4 times 6 is 24. Okay, and then I'm going to distribute the 4 to the 3, and it's a positive 3, so that'd be 12. And what's 24 plus 12? Of course, it's 36, and as you notice, either way you get the same answer. But what about if you had something like this? Now we have a minus sign in there. So can I use distributive property? Well, yeah, you still can. It works for both problems where inside the parentheses you have either addition or subtraction. So using distributive property here, I would say take the 7 times the 3. That would be a positive 21. Next part, I would say, now I have to take 7 times this. Now, what is that? Well, it's a 5, but keep in mind, the sign to the left of it is a minus sign. So, minus 5 is really just like saying negative 5. And we know that 7 times negative 5 is going to be 35, but then negative, so negative 35. So what we get here is this 21. And then that equals negative 35, so I plop him in right there as a minus 35. Okay, so 21 minus 35, well, that'd be like 35 minus 21, and that gets you 4 and then a 1, but we're talking about 21 minus 35, it's going to be negative, so I slap on the negative sign there at the end and pretend that didn't exist. 21 minus 35 gets you negative 14. So I want you to take a minute and I want you to try these two. Using the distributive property, I want you to take negative 3 times the quantity, 4 plus 10, and then I want you to take negative 6 times the quantity, 12 minus 7. Alright, use the distributive property there on both those. Play it when you're done to see if you got the right answer. Okay, so hopefully here you said, I know I have to take this number that's outside the parentheses times the first number on the inside, which would be a 4. So negative 3 times a 4, okay, that would get you, well, negative 3 times 4 is negative 12. Now you have to take the negative 3 times the positive 10, and that's going to get you negative 30. So now you have negative 12 and negative 30, which we can rewrite that as negative 12 minus 30, okay, and that's like saying 12 plus 30, which would be 42, and then you make it negative, because you're having a negative minus a negative minus a positive. Otherwise, you could think of it as, it's negative 42. You could think of it as you have a number line, you start at negative 12, and you move 30 to the left, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. If that was 30 spots, that would get you to negative 42. Alright, this one here, Let's see, what I would do is I'd say negative 6 times positive 12. That gets me a negative 72. And then I have a negative 6 times a negative 7. Negative 6 times negative 7 gets you a positive 42. So negative 72 plus 42, that's like being on a number line and saying I'm at negative 72. I'm going to add 42, which means go to the right 42 times. So let's pretend there's, 42 of those. And that would get you negative 30. That spot right there, if you move 42 times, would be at negative 30. All right, so sometimes, though, we're going to use the distributive property but not get a final answer, such as negative 2 or 5. Right? Sometimes we're just going to have to write what are called equivalent that says equivalent variable expressions. Equivalent variable expressions. So what does that look like? Well, if you were given 3 times the quantity x plus 2 and told to write an equivalent variable expression, what you would do is, well, let's see, could you use order of operations and do what's on the inside of the parentheses first? Well, x plus 2. Well, x and 2 are not like terms. You can't add variables and numbers, so actually you couldn't. So if you just knew order of operations, you'd be stuck. But now that you know the distributive property, what you can do is distribute the 3 to the x. 3 times x is 3x. And then distribute the 3 to the positive 2. Positive 3 times positive 2 is positive 6. And that right there is your equivalent variable expression. What if you were given something like this, though? 6 is on the other side. Well, it actually doesn't matter if the 6 is there or the 6 is here. Now, I will say, generally, you won't see the 6 there. So if I ever see that, I just move it to the other side and rewrite it as 6 times 4 plus n. Okay, and then I say, all right, distributive property, 6 times 4 is 24. 6 times n is 6n. And I'm done. I can't go any further with that. All right, so let's say we're given this figure here, okay, and the length is 2x plus 5, and the width is 7. Okay, and what we want to do is we want to write a variable expression that represents the area of this black figure. Okay, so we're going to write an expression for the area. So area of a rectangle is equal to the length times the width. Okay, we've known that for a long time. But what is the length in this case? Well, it's not like 4. It's actually, or just some number. It's the quantity 2x plus 5. Okay, came from right there. Now we take that length times the width. Okay, what's the width? In this case, it's a 7. Okay. So how does the distributive property help us? Well, if you remember, if I have 2x plus 5 times 7, I can rewrite that as 2x plus 5 parentheses and then 7. I don't have to have that multiplication sign there. But once we get there, you remember my little trick of moving the 7 over here. So now we have a is equal to 7 times 2x plus 5. Now, why does that matter? Well, now you can use the distributive property. And you could have before, but this is just a shortcut to put it in typical distributive property format. Anyway, now I could actually call this right here as, I could call it an expression that represents the area. But generally, we want to get rid of our parentheses if we can. So let's use distributive property. 7 times 2x. Well, what is that? Well, if you think about it, it's actually like saying 7 times 2 times x. And, well, 7 times 2, I know that's 14. Don't have anything to multiply the x by, or no other variables, that is. And so I get 14 times x, and I can just rewrite that as 14x. Now, what about 7 times the 5? Well, 7 times 5 is just a plain old positive 35, so I could just tack on the positive 35 there. And guess what? This is the expression that represents the area of that figure right there. All right, guys, that is the 2.2 video about distributive property. Hope you enjoyed it. I'll see you in class.